Welcome to another video, and today I'm going to summarize all of trigonometry. Firstly, we have SOHCAHTOA. Now, this is just a short way to remember it, but what it actually is, sine of theta equals opposite over hypotenuse, cosine of theta. Theta is just whatever the angle, so I can name this theta, equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. So let's look at this problem here. You have a opposite, that's good. You have an opposite, tick all of these. So you obviously are not going to be using cosine at all for this specific problem. So you also, it's a right angle triangle, so you're going to be using a hypotenuse. Now, SOHCAHTOA works for right angle triangles. Here you have a hypotenuse, so you got a hypotenuse and an opposite. It can't be tan theta here, it can't be that as well, because it doesn't have a hypotenuse. So we're going to be using the sine ratio. So sine ratio says the sine of the angle. We don't know the angle, that's what we're trying to work out. So let's write this out. Sine of x equals opposite. Your opposite is this, 5 over your hypotenuse. Your hypotenuse is opposite of your right angle, so you're going to get 16. Now you want to cancel out the sign. You want the x on the left side. You want to find out just what x is, not sine of x. So in order to do that, you're going to have to inverse sine both sides. So you get inverse sine of 5 over 16. And you figure that out, which is going to be 18.2 to whatever decimal place. The one here in this case is 1 decimal place. So it's really simple. Sometimes you'll be given sides. So for example, you might be given a hypotenuse and an opposite, and you might be given an angle, a hypotenuse, but you'll always be not given one information, which might be the opposite in this case. So sine rule: a right angled triangle, if you have a right angled triangle, you're going to be using either SOHCAHTOA, or you're going to be using a squared plus b squared equals c squared, which is the Pythagorean theorem. If not, you're going to be using the sine rule, or cosine rule, which is what we're going to be looking at now, the sine rule. And that, you gotta always look at that for whatever your thing is. Now here you can go even deeper. If you have an angle, so then you can look at, if you have an angle, if yes, you're going there. If you're given an angle, right? If you're not given an angle to work with, then you're just going to be using Pythagorean. So now your small a's, b's, c's, they usually represent the side, and you use the big A's, the uppercase C's. These are used for the angle which is opposite that side. So for example, you have a length A, and opposite that length is an angle which is A, uppercase A. So they both correspond. The B and opposite B is the angle B. So these are angles. Okay, now the rule says A over sine A equals B over sine B equals C over sine C. So in this case, your A is your x, which is what you're trying to work out, over sine of 38 equals b 13 over sine of 100. You're gonna just cross multiply, get yourself 13 sine 38 over a sine of 100. You're going to be using obviously a calculator for this question, unless it tells you, unless of course it's a non-calculator paper. For non-calculator paper, which is what we're going to be going after we look at cosine rule, you're going to be using the trig values, which you have to know and memorize. So here you're going to get 8.1 to 1 dp. Okay. You times by sine A both sides. A equals b sine A over sine B. Times by, now that you've done that right, you can times by sine B both sides. So you get A sine B equals sine of A. I mean, yep, there's a B there. I forgot the B. You divide by b both sides, so let's just write it backwards here. So you divide by b both sides, you get a sine b. B equals, yeah, that should be correct, sine a. If you times both sides by 1 over a, you're gonna get ba at the bottom. And if you're getting ba at the bottom, that can cancel out with the top. So you're gonna get sine b over b equals sine a over a. And you can do that for sine, you can prove that for c as well. And you're just gonna get this sine c over c. So cosine rule. So the cosine rule states a squared equals b squared plus c squared minus 2bc cos of angle A. You can rearrange this again, just like how we did with the last one. You can rearrange this. Well, what you can do, take away a squared both sides to get b squared plus c squared minus 2bc cos A. I missed the c, cos A equals 0. Where's the a squared? Minus a squared equals 0. What you can do now is add 2bc cos A both sides, because it's just one entire thing, and you add take away a squared equals 2bc cos A. You can divide by 2bc. What you do, divide by 2bc, you get 2b squared plus c squared minus a squared over 2bc equals cos of A. And there you go. That is your next formula that you can use for angles this time. This time for angles, you're usually given, I mean, mostly you are given 3 sides. You're given 3 sides for like one triangle, and you're gonna have an angle in between that you're gonna have to work out. So you're gonna have all your A, B, C's. Again, one angle this time, angle cos A. This is also another thing you need to know. You will need to know this inside out. You can't, usually some questions that you'll get on the non-calculated paper, you will have to use your knowledge to know what these values are for both sine, cos, and tan. So those are all the values you need to know for trig. Now coming on to 3D trigonometry, there is nothing which I'm going to say about this, because all you need to know. So for this, all you've got to do, you got to apply all your knowledge of SOHCAHTOA and all your other things. Thank you for watching, and I'll see you in another video.